So I'm John Langford. This is about the custom decision service, which is a new cognitive service. It's something which is essentially new in the world. There's nothing else quite like it. I'll show you what it's about and discuss things in greater detail. Okay, so let's start with an example application. This is a real application. So MSN came to us and they said, we would like to personalize the news articles that are displayed. And we believe that if we personalize the news articles, that will really help drive engagement, which is just really good for MSN. So we did that. So this is called the info pane. This is called the river. Both of those are personalized now for all the logged in users. And when we did this, we found that you needed to do machine learning in a different way than is typically done. And the gains were actually very substantial. We had a more than 25% increase in click-through rate as we were personalizing things. Okay, so that took us probably about 2 years to really push that through, and that was several people working over that time. So what this is really about, the decision service, is it's about the core technology behind that, and in particular right now, it's about taking that 2 years of effort and turning it into maybe an hour of effort for somebody who wants to use this to personalize any kind of content on the web. Okay, so let's do a demo. So this is a demo that you could actually do yourself. Uh-oh. Interesting.
To switch me.
So if you go to that URL, you will see what I'm pointing at. And I will go there. So this is just a little toy demo. We're trying to recommend one thing or another. And each of you can choose for yourselves whether or not you like a news story about a growing consensus on the need for an international treaty on nation-state attacks, or something about Satya. I will go for something about Satya. And I can click on things. It tends to explore different alternatives. And over time, it learns what each individual person, so if you in the audience wanted to do it, all of us at the same time, it would learn what each of us wants, and it would start surfacing that over and over again. So now it's starting to learn that Satya is what I wanted. So a key question is sort of what's going on here, and we made a little process to show you. So you have some web server where you post an RSS feed with maybe some articles or other content. The decision service goes through, it can back in on other cognitive services to turn like a picture into some interpretation of what the picture is about. It sends features into the decision service, and then later on, a user comes. Let's do it again. So it goes back and forth. You send content. There's a choice. The decision service tells you how to rank things. The user clicks on something, and then there's a reward signal that goes back to the system itself, right? So we're kind of capturing all the information needed to make a good decision, and then we are trying to make good decisions. So Marcus here will tell us how to integrate this into a web page.
So when you're in a web-based scenario, it's quite simple. You just need to include that script tag at the beginning. If you look here, there's the demo. That's like your ID that you choose, what you want to be in there, so we can identify you as a customer. And you have the resend, which identifies the RSS feed that you registered with us, and you can have multiples. That's the way we can get your articles. And then we will call back a callback function that you give to us with the ranking. And the code that you see here is sample code from us now on how we could imagine that you render it, but it's your web page. You render the article information on your page. And then the last item that you need is you need to send us the reward for it. So when the user clicked on the top item, on Satya in this example, you need to make a simple post request to our service and tell us that the user clicked on it. Yeah.
You want to do the next bit?
Oh yeah, and so if you're in a single page application and you want to get repeated personalization ranking requests from our service, we have a simplified version that works well with jQuery, where you can just ask us again and we'll give you a ranking for the RSS feeds that you registered with us. And then you have the same model as above with reporting the reward to us.
Good. Okay, so that's the basic idea of what's going on to some extent, and there's kind of a question about what is the scope of where you can easily apply it right now. So there's several things that you want to have as characteristics of the problem you're trying to solve. You want there to be many decisions. So for every user coming to a website, which news article do you want to display is a good example, because there's a lot of users coming to the website, and so there's a lot of decisions which are very similar in nature. You want that the decision that you're making kind of affects the outcome in a significant way, right? So displaying the choice of news article probably does have a significant impact on whether or not a user actually clicks. You want that the number of available actions is not too large. So in MSN, the way this works is there's kind of a pool of articles, but there's various ways to weed down to a reasonable set of plausible alternatives. And then the system can really optimize on that plausible smaller set of alternatives. And then you want things to be kind of web capable so that you can interact with the API. Okay, so I'm going to give you a little bit more of a sense of how things are working behind the scenes. So you have kind of users and articles which are going to the front end, and then a ranking is coming back. And that's the basic loop that we showed you before. And now, later on, so as a side effect, we're logging this information and sending that towards a learning algorithm. But you don't learn from that yet. Instead, what happens is a user clicks or doesn't click on something, and then that information is joined before it hits a learning algorithm on the back end. So this loop here takes milliseconds time scale. This loop here takes 30 seconds in the demo that I showed you, and maybe 5 minutes in the case of MSN. Okay, and then periodically you checkpoint the model, and you push the model into the front end, where it can be hit over and over again at arbitrary scale. So right now you can do things like news personalization or image. You can choose which image to put up, or you can choose which banner to put up, things like that, which are relatively easy on the web. Okay, so we noticed that some of the press is a little bit off about the decision service. So I want to be as clear as I can about what it is, because it's actually something which is new, which means it's not, I can't say it's an X, because there is no other X of the same type. So this is not just A/B testing. There is a relationship with A/B testing. In particular, we can do evaluations of policies with the same statistical strength as in A/B testing, but that's not the goal of the system. The goal of the system is really optimizing, doing the machine learning in order to do personalized news or, in general, contextual decisions. So it uses machine learning, and it kind of improves constantly based upon the information that it's getting. This is also not typical supervised learning. Most of what you see in machine learning, who's done machine learning or knows about machine learning? A fair bit? Yeah, so most of what you see is supervised learning, which is actually creating a lot of buzz. This is a different kind of machine learning. The key difference is that the decision service collects its own data. And we've designed the system so that it collects the right data so that it can constantly improve. Most other learning algorithms just don't even have a notion of gathering the right data. That's not even built into their system. So this is something new, and that's as close as I can get at a very high level talking about other systems. Okay, so Right now, you can do content personalization. We have plans for the future. The basic technology is much more widely applicable. So we want to do more general content personalization, maybe for videos, things like that. Maybe we want to do infrastructure management. So in particular, maybe you're at Microsoft and you have a cluster called Azure, and there are virtual machines on that cluster, and sometimes these virtual machines become non-responsive, and now you would like to know when you should actually migrate the virtual machines to some other real machine. Or maybe you want to think about customized pricing or customized couponing for individual customers coming to Starbucks or coming to look at offers for airlines or things like that. Or maybe you want to think about supporting wellness in people. Maybe people need reminders about how often they should walk. That's kind of a new thing these days. And maybe we can use the decision service to choose the kinds of reminders that work for individual people so that people become healthier overall. Or maybe we want to figure out how to, we want to create kind of a new class of user interfaces which actively interpret, try to figure out what the user is trying to do. I would like my keyboard, so there's certain things that I mistype in my keyboard. I would like my keyboard to just learn that I mistyped them and fix them automatically, right? I mean, that's certainly possible with this kind of technology. And in general, I think there's a good bit of insert your imagination here. So all of the things that I just talked about are actually things that we have played around with at like a demo, prototype, or whatever phase internally. Okay, so let me tell you a little bit about what exists now and what our future plans are. So in general, for the decisions that are being made by the decision service, I think the degree of trust that is needed for the system must be very high, because it's something which is very deep in the loop of whatever you're trying to do in the real world. So the plan is, well, the system is set up so that the data rests in your Azure account. So if you sign up to the decision service, it will do the learning, but the logs will be going to your account, and then you'll be able to do your own learning and use the logs offline as you wish. The system is actually open source. The core algorithms are open source. It's a Vocal Wabbit. It's a online learning system that I've been working on for some time. And then we want to set up, we have some monitoring, but we want to set up substantially more monitoring to make it work better, to make it so that, well...
Statistical monitoring.
Yeah, so the statistical monitoring and systemic monitoring, and both of those are very important. So faults shouldn't happen. Okay, so there's a good bit of flexibility. Right now you can do things on the cloud, but there are applications clearly where you must have much lower latency than you can get from the cloud. And so we have plans, well, we have more than plans. We have a library even that allows you to do this on device. And then another big bit that we've been working with is some people want to manage the Azure services behind the system themselves so they can kind of tinker with everything. Others want us to manage things. And both of those options are available to some extent. Okay, so then another thing that you want is kind of a good integration with a lot of other systems. Right now, there's about a half dozen cognitive services which are integrated into the back end. If you use the right schema in your RSS, it can just call into those backends and featureify images or try to get sentiment analysis from the text or things like that. We're working on more advanced algorithms as well, and we're also integrating some other learning algorithms so that you can try to, so you can have fun. Okay, so in general, the goal is to unlock all of those other application areas so that that can be used at scale all around the world, and then good things can happen. So I want to show you a video of a demo that was made using the decision service inside of Microsoft.
Of us take speech for granted, but not everyone is that fortunate. Each year, nearly 20,000 patients are diagnosed with ALS. Over 500,000 people suffer strokes with subsequent paralysis. In the most severe cases, patients can lose both their ability to move and their ability to speak. While technology exists to help these people communicate, it is both expensive and highly specialized to certain types of movement. What we wanted to understand is whether we can provide these patients with a mechanism to communicate using an affordable piece of consumer hardware. An early prototype combined a built-in gyroscope with the latest machine learning technologies, enabling patients with sufficient head mobility to draw letters, which are recognized and formed into words. However, like most existing technologies, this required the patient to be able to repeat a well-defined action. But every person is unique, both in which muscles they can move and in how much control they have over that movement, and these can even evolve over time. So we've taken this one step further. Using Microsoft's custom decision service, patients can actually train the system to associate specific movements with a particular letter, essentially creating their own alphabet customized to their individual capabilities. The hardware is equipped with electroencephalograph, or EEG sensors, which measure the electrical activity in the patient's brain. These sensors allow us to detect voluntary facial movements, such as intentional blink patterns, which can be further mapped to the patient's custom alphabet. Feedback is continuously being provided to the adaptive learning system so that it becomes more accurate the more the patient uses it, even learning from past mistakes. In addition, the EEG sensors can be used to infer a mental state. By focusing on a particular thought, such as a complex math calculation or relaxing on the beach, the patient is able to influence the frequency pattern of the detected electrical activity and, in essence, communicate with the power of his mind. What we have shown you is just the tip of the iceberg, but this rapidly advancing field is providing hope to thousands of people around the world today.
So that's using the decision service. That was something that my friend Aiden worked on. It's not for release, but I think it's an example of how you might stretch your imagination. This is an example of the user interpretation application of the decision service, trying to figure out what the user is really trying to say. So with these capabilities in the future, we can imagine that interacting with computers might become much more natural, and we have a better world in various ways. If you're interested, there's a case study with Complex, which is an external company that was just released yesterday, I believe. The website is ds.microsoft.com. The core algorithms are all open source. There's a systems paper behind this. I'm in Microsoft Research, so we write papers. So you can understand how the technology works in much greater detail than I've had time to go through right now. So this is kind of a unique thing, and I would encourage you to imagine a bit about the scope of what you could do, and pester us when you can't do that yet. And we will try to make it so that you can. Are there questions? Say again?
Pricing.
Oh, pricing is free right now. What more can we say?
It will take a bit, right?
It'll take a little while before we work out with pricing, but the plan is to...
Oh, yeah, about the application, he wants to personalize the pricing on his end, right? He wants to...
Oh, right, personalized pricing. Yeah, so...
The feedback is if they buy, right?
That's close to what we can do right now.
Well, you can you bucket it?
The key difference between that and what we have right now is that with clicks, it's just 0-1. But with pricing, you actually want to say something about revenue or profit, right? And so that's just a small change in the interface, which probably can happen pretty quickly. Yeah?
the constraint around that?
Let me just repeat the question. Why this set is restricted to 20 items only, Sean?
Yeah, so that has to do with the mathematics. It's not actually 20. That's just a representative number. And it depends on the application, exactly how many different choices can be made. But the system is actually exploring over alternatives. And so if the number of alternatives is too large, it's going to take too long to explore over them to find what the right choice is. Right, so in general, you want to select to a set of plausible alternatives. And then the decision service can use feedback to figure out which one of those is really the best.
Maybe let me add that there, if you think about the MSN use case, right, the number of articles over a day is way larger than the 20. The 20 is only at one point for a particular decision. That's where we need to rank down. But if you can ask the system now and give us 20 options and we'll pick, and then the next second you can ask us with 20 different options. They can be different articles next time. It's just they have to be, at one point they have to be less than 20 or some number.
Could you circumvent that by possibly doing the super service for sets of 20 and then doing a pairwise comparison among specified items?
Can you circumvent that by using groups of 20? No. It won't work that well.
50, 20, or is it the different features which are important?
It's really the features underneath which are important. So you need to, okay, so there's the number of alternatives that you explore amongst, which is maybe the number of news stories or letters or whatever it is. And then there's the representation underneath. So for the content personalization application, we have some baked-in set of features. So there's no data science expertise needed to use this. A programmer can use it. It really is the case that with an hour's effort, you could deploy this. For the more advanced applications that I showed you, including that one, a data scientist is really required. And the choice of representation becomes very important in how you use it.
You still won't get past the 20.
Read the systems paper. That's really the answer, I think. Other questions?
A silly question. You said this isn't similar to anything else, but it sounded to be kind of similar to multi-arm bandit. Is it an old kind of...
So the core technology behind it is a contextual bandit. So in a multi-arm bandit, typically you have no context. So you have no features. You have no way to generalize from one person to another. And that means that for every individual person, you have to explore a great deal. But here we're doing contextual bandits. So the features come into play, and that allows you to generalize across all the different users and learn much more quickly. All right, thank you.
Thank you.